Now we have our ideas about inputs and outputs, but I want to look at why that is. So if we have an input of 1, we know from our function machine that our output was 2, but why? If this is our function and we plug in f of 1, that's like saying 2 to the first power. 2 to the first power is just 1, 2. It's 2. If we think about our function machine when we plug in 2, f of 2 is 2 squared, also known as 2 times 2, or 4. So when we plugged in 2, we got 4. And f of 3 would be 2 to the third power. That was supposed to be pink. Or 2 times 2 times 2, also known as 8. When we plug in 4, f of 4, now I'm mixing up my colors, is 2 to the fourth power, also known as 2 times 2 times 2 times 2, or 16. And finally, when I plug in 5, f of pink 5 is 2 to the fifth power, or 2 times 2 times 2 times 2 times 2, also known as 32. Now, if you're really good, you may have noticed that there is some kind of pattern to these numbers here. There's some like two-ness. Not only are they all even, but every time you go down 1, 2, 2, 2, you're multiplying by 2. 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32. And the reason for that is what the nature of the exponent. We're having another 2 being multiplied in. So we are going to take this concept and we are going to practice it a little bit. Don't worry about these spaces here. We'll come back to them. But what I would like you to do is, before watching the next video, fill out tables for f of x equals 3 to the x power and f of x equals 5 to the x power. If you're still feeling uncomfortable with the idea of f of x, that's okay. Just think of it as y. The number you plug in is x, and the output is y, or f of x. I'll see you in the next video.